Hello students, today we will be seeing the working of the center tapped full bridge rectifier, center tap full wave rectifier. Okay, in the previous lecture I have shown you the model of a single phase full wave bridge rectifier. Similarly, I have told you that in a full bridge rectifier there are two configuration. Either we can work it in a full bridge rectifier scheme, or we can also use a center tapped full rectifier, full bridge rectifier. So here, as you can see, this is the circuit. Here we are having the supply, then we are having the transformer, then we have been using the diodes, and then we have the load, which is a resistive load. Here for simplicity we have taken the resistive load, and this is the scope where we will be analyzing the results. Okay, in a full wave rectifier what will happen, both the two halves have to both the two halves of the supply that has to be rectified, and it should in the output it should look in a unidirectional, it should look like an unidirectional waveform, right? So I have run this model, I have made it and I have run it also, so I will show you how it looks. So this is the waveform na? So this one is the input waveform and this one is the output waveform. As you can see in the input waveforms, there is positive half cycle, negative half cycle, whereas when you analyze the output waveform, we can easily see that all the waveforms are only in the first half or in the positive half. No waveform is in the negative half cycle. So this shows that the input waveform, which was AC, has been now converted into DC. Yeah, there are ripples, but this is a pulsating DC which we will get with the help of a single phase center tap configuration. Okay, so let's see how we have to make this circuit. Okay, how this circuit can be implemented. So first of all, like I have told you, for implementing this circuit you need MATLAB software. First of all, install MATLAB software and then double click on it. The first interface you will get, it would look like something this would be the first interface that you will get. Okay, after you have seen the interface, next is you have to open a model. For Simulink, for simulation we need Simulink model. Okay, so you will double click on the Simulink model and then this canvas is going to come, and in this canvas we have to drag and drop the elements required for the model, which can be brought from the library browser. Just double click on it. After double clicking on it, all of the components which has been used in this particular model was taken from this particular library browser. Okay, and we have been working with the simscapes. Electrically in electrical we use the simscape. Okay, so major of the components or the elements which we are using comes from this only. Okay, so yeah, 1 minute. One more thing, I have been talking about the Powergui which we are using here. So many of the students have a confusion, why do we use this Powergui? The reason being we are using the Powergui is that see, in this fundamental blocks in the Simscape we use the specialized power system. In the fundamental block, whichever component if you are going to take, obviously when we are making this particular circuit we need the components like the supply, the diodes which will be coming from the power electronics library, then we need this transformer, we need this load, we need the measuring elements, everything. It is coming from this specialized power system fundamental block library, right? So if you are using any of the components in any of these shown libraries, na, you have to by default use the Powergui, otherwise you will not be able to see the waveform. In a simple case, if you are like you just want to visualize the sine wave, for instance, okay, so you can go and you can, from the source, maybe you can take a sine wave. Okay, you can take a sine wave, and you can take a sink. From the sink we can take the scope. Okay, add to the library, this thing only I have added it. So these are the two things which I have added. Okay, now what I'll do, I will just copy it and I'll just use this here. Okay. Now when I am going to run this thing, I don't need a Powergui unit, because both of the components have come from this source and the sink, where Powergui was not required. Powergui was coming only in the specialized power system units, and fundamental blocks I showed you. Here it is coming. Whichever element, if you are taking it from here, like if you are using some resistor, capacitor, etc, etc, power lab, if you are using something from there, then you need a Powergui unit. Otherwise, for every other thing you don't need a Powergui unit to be connected. Okay, so let me just show you. Here I have not used any Powergui unit. First of all I will have to save it before running it. So I will save it. Okay, now I'll just run it. Okay, I'll reduce the time to 0.05 only, and I'll run it. Because it was only 0.05 seconds, so you are getting this waveform, and if at all I will be like increasing the time, say 1. So or say 10. Now you can see a complete 1/2 cycle of the sine wave. Okay, so in this way I have just shown you that here you don't need a Powergui unit, but in our case the center tap Fullwave rectifier which we are using, we need a Powergui unit, because all of these components have come from this library. Okay, from where it was coming, specialized power system library, fundamental blocks. Okay, so this is a question which usually students have, so I was just clearing it. Okay, now coming back to how are we going to implement this particular circuit. For that, what do you need is, first of all we need a supply, AC supply, which we will be getting from here, electrical sources. Just right click, add to the fundamental block. Next, what do you want? We want a transformer, linear transformer, we want diodes, we want measuring units. Okay, we will bring all of it. We will go to elements, branch, series RLC branch I'll be using. You're not using the RLC load, because in the RLC load we have to specify what is the active power and reactive power, everything, whereas in this particular example we don't have a need for that, so we are using the series RLC branch, which will do the same. Okay, next we want is a measuring unit. In the measuring unit we want the voltmeter, because we have to find out the measurements of the, we have to see the waveform of the input waveform and the output waveform. Okay, after that we need a transformer. You can here write, we need a linear transformer. because there is no provision for center type transformer. Your diode also we want, so we'll add diode. Yeah, so here we are having, yeah, this is the linear transformer which we want, we will add it. Okay, also we need a ground, so that will come from, yeah, here is the ground. Okay, so we are having all the components which are needed for building this particular model. We'll just drag it. We are taking R load itself. Okay, for our convenience, control R, we will just rotate it. We can rename it also. I'm seeing them where we can change the name, but there is an option. I will tell you in the next model I will show you. Okay, so just attach these points. We need a ground because it is a center tap, so we want 2, है ना? Then you want supply. Next we want the measuring units, so we want voltage V1 here also, and we want voltmeter here also, voltmeter to voltmeters we want. It's not getting a point, so I will just have to yes, now at times it happens because it is not getting particular point to get attached, and therefore it is showing that red color. Okay, so till that time this red color is there, that means the connection is not yet set up, so you have to make it sure that the red color never comes while you are connecting the components. Red color means that there is disconnection. Then you also have to use the go and the from blocks for visualizing this thing. Okay. And scope also we want, and slow scope also have not draw, so I will go to search here. So here I'll get from, and I'll also get go to. I have added it, and then I need a scope, so the scope will come from here, sinks. In the sink you have the scope, you can add. Just rename this, say it is B, apply OK, and I'll call it B1, because there I have given the name A1 and A2 na, so it will get confused. And then we'll generate an error. Okay, double click it, because we want two input ports, two ports in that particular scope. So 2 ports. Okay, and how do you want it to be looking like? It should look like something like this. Okay, just close this and attach it, double click this, identify. I want to see B1, that is the input out voltage, and then I want to visualize the B1, so just apply and OK. The Powergui unit is already there. If at all it was not there, you have to bring it from the fundamental blocks I just showed you. Okay, so we are almost done with this particular circuit. The one important thing which you have to do is you have to change this. Okay, so I will be just changing the nominal power and the frequency. Let's say 5. Okay, now we are going to run it. 0.05 time I have kept. Okay, and then we will be seeing how our waveform looks. Yeah, see. Okay, this was the input waveform, this is the output waveform. The input waveform is AC and the output waveform is DC, while sitting DC. Okay, and again I have told you, you can always use the legends, so it will give you the measurement, voltage measurement 3 and voltage measurement 2 it is showing. In the next example I will show you how we can correct it. Okay, and also how we can make these graphs in different, that I have already told you. That is like, go to the style, and you need to do is usually we keep it like this so it looks good, and take the line width as this. If you can also use markers if you want to just make your graph look a bit different or something, you can always do that. Okay. there is no need, so you can just keep it simple. So this is your waveforms. Okay, using the center tapped full bridge rectifier. So hope you all of you understood how this particular thing is working. Okay, thank you.